Hey everybody, we're going to continue in our review, chapter one review, and we'll do now just exponents. And we'll start with a couple of laws here, a couple of exponent laws. One is that number one is that x to the a times x to the b. In other words, when I multiply two exponent numbers, I add the exponents. This is all assuming you have the same base. The base is all the same. Second law is if I divide two exponent numbers, this is going to be x to the a minus b. So when I divide, I subtract the exponents. I'll give you examples of all of these. And the third rule is that if I raise a power to a power, this is going to be equal to x to the ab. So when I raise a power to a power, I multiply the powers. So let's just do some examples here. X to the second times x to the third. Well, let's just see where this rule came from. This x to the second is x times x. X to the third is x times x times x, and I'm multiplying them all together. And there are 1, 2, 3, 4, 5 x's. That's 2 and that's 3. So 2 plus 3 gives you my 5. That's really why you add the exponents. X to the fifth divided by x to the second equals x to the third. And that makes sense also because x to the fifth is 5 x's. X to the second is 2 x's. Those 2 x's cancel and I have 3 left. I'm just kind of making a little sense out of these. X squared raised to the third power is equal to x to the sixth power. That makes sense also because this is really x squared times x squared times x squared. And that's my first x squared, my second x squared. You have 1, 2, you have 3 groups of 2. 3 groups of 2 is 3 times 2, which is 6 x's. I'm just kind of just explaining where these rules come from. I guess another rule would be that xy to the a power is equal to x to the a times y to the a. So 3 times 7 to the fourth power would be 3 to the fourth times 7 to the fourth. And feel free to work this out on your calculator. In other words, we're saying that 21 to the fourth, 3 times 7 is 21. So on your calculator, you could do 21 to the fourth. You could also do 3 to the fourth times 7 to the fourth. You'll get the same answer. And our next rule is that, similar to number 4, is that x over y to the a power is equal to x to the a over y to the a. So 3 over 7 to the fifth power is equal to 3 to the fifth power over 7 to the fifth power. Those are my rules. Now, there are 3 more things I want to give you that I want to know. They're not rules that you prove. They're really more like definitions. So I'm going to call them definitions. So these are exponents. So these are so 6. If you have x to the 0 power, that just equals 1. 7 is if x to the negative n power is not a negative number, it's a reciprocal, it's 1 over x to the n. So x to the negative 2 equals 1 over x squared. 3 to the negative 3 is equal to 1 over 3 to the third, which is equal to 1 over 27. And of course, 5 to the 0 power equals 1. That's an example of this rule. And the last rule I want to give you is if you have a let me move up here a little bit. And again, it's more of a definition than a rule. If you have x to the 1 over n power, that means the nth root of x. So 5 to the 1/3 power is equal to the cube root of 5. And that's just a definition. That's just a definition. Now, what if you have x, what if you have a fraction, m over n? So x is raised to the m over n. So in this case, the m is the exponent, the n is the root. So this becomes the nth root of x to the m. And we're and that's all my rules and my definitions. By the way, one could also uh, so let's look at an example here. So first I'm going to raise this out. So this is going to become 8x to the 6th times 4x. Now the 8 and the 4 just become 32. X to the 6th, now there's like an invisible one there. X to the 6th times x to the 1st is x to the 7th. That's my first example. If I want to write 5 over x to the 3rd with negative exponents, that's just equal to 5 times x to the negative 3 power. Suppose I want to rewrite this whole thing using positive exponents only. So well, when you have a power to a power, you multiply the power. So this becomes on top x to the negative 4, because 2 times 2 is 4. And on the bottom, I have y to the negative 6, because negative 3 times 2 is negative 6. Negative 2 times 2 is negative 4. Now, a negative on top is the same thing as a positive on the bottom. So a negative 4 on top becomes a positive on the bottom. A negative 6 on the bottom becomes a positive on top, and that's my answer. And why is that? Because the negative exponents are reciprocals. So it sends it from the top to the bottom. This sends it from the bottom to the top. And let's do another example. Let's rewrite this using exponents. So this is just going to be 4x to the 1/2 power minus 3x to the negative 1/2 power, because the square root is a 1/2 power, but if it's a reciprocal, so it's negative 1/2 power. If I want to write this with positive exponents only, so it'd be 4x to the 1/2 minus 3 over x to the 1/2. Which, now students will ask me, well, which way should I write it? This way or that way? It really depends on how the question is phrased. If the question is phrased positive only, then there you go. If the question says no fraction bars, you do it this way. If the question doesn't specify, you could use either answer you want. But how you express something really depends on what the instructions of the question say. Let's express this square root of p to the 5th to the negative 3rd power. I want to express this with positive exponents only. No radicals, only positive exponents. Well, first of all, square root is a 1/2 power. So this is equal to p to the 5th raised to the 1/2 raised to the negative 1/3. Basically, it's a power to a power to a power. You just multiply all three powers. So this is going to be p to the negative 5/6, which is equal to 1 over p to the 5/6 power. And that is, and there you go. That would be my answer with no radicals and only positive exponents. Let's do another one. Let's rewrite x to the negative 4/3 as a radical. Well, this is equal to 1 over x to the 4/3. And this is equal to 1 over x to the 1/3 to the 4th, because 1/3 times 4 is 4/3, which is equal to 1 over the cube root of x raised to the 4th power. Well, everybody, this concludes this exponent video, and we'll see you guys and of our chapter one review, and we'll see you guys next time. Bye.